Camden is also an undergraduate student. He's in his third year of computer engineering software at the University of Alberta. And we were fortunate that his program has internships. And so we were fortunate to get Camden with CROSH pretty much for the past almost a year, Camden? As part of that program. So sorry, I better focus here. He's going to cover how being a, oh, sorry, I said that. It's the end of the day. Apparently I'm getting off focus here. His interest in occupational health and safety has stemmed from the use of various technologies used in research to improve the well-being and work lives of the people in the labor force. And he's going to present some of the things that he's been doing now. And that's a nice looking slide. I can hear you. If you want to start, you're all good.
Okay, thanks for the introduction. Welcome everyone to the final topic in this session of field evaluation. My name is Camden, and yes, I'm an undergraduate student at the University of Alberta. I'm studying software engineering. Recently, I got to work with CROSH, supporting some of the technical aspects of various research efforts, as well as just learning about the complexities of field research and the research process in general. While I was there, I got to work with a couple different types of sensors. However, working with them in a lab setting offered the perfect working conditions for these sensors to operate in, and there were still very many challenges to overcome. Data collection through sensors is much more challenging in the field, which have many external factors impacting the process. So this is field evaluation, field challenges in data acquisition from different sensors. So first we'll go over why understanding these challenges is important for research and for workplace health and safety. Then we'll talk a little bit about how this might be applicable to you. Then we'll go over what sensor data acquisition is. And from there, you can even start to think about some of the challenges that might arise in the process on your own. Then we'll spend the rest of the time talking about the external challenges related to using sensors in the field, and then we can bring it all together. So how does understanding these challenges improve research and workplace health and safety? Well, it allows us to come up with strategies to efficiently deploy sensors in the field, which collect meaningful data. And this data is used to get an accurate picture of the working conditions that the workers are subjected to. And this allows us to make decisions and recommendations to improve their long-term health and their immediate safety at work. Sensor data acquisition in the field now goes beyond just research, as many industries are incorporating sensor use into their health and safety plans, or just to assist in day-to-day operations. In a technologically advancing world, many of us will encounter sensors and maybe even have to deal with some of their challenges. So it's important to realize that they aren't perfect systems. Sensors are made with a greatly varying degree of robustness, and some can be as comprehensive as a smartphone, while other low-cost sensors contain few basic hardware components that might be limited to a single chip. Again, awareness of these challenges helps ensure that the data acquisition is accurate and reliable and useful. If you're a health and safety professional, understanding these external challenges posed by the field can help with effective risk management, informed decision-making, and improved safety protocols. If you're a worker in the field, realizing what goes into deploying these will help you stay vigilant when working them. You can also start to think more cautiously about the sensors that might be around you at work, understanding how many people are interested in how your work is affecting your health. You might also get the opportunity to participate in field research that will drive change for the future and improve the working conditions for the generations to follow. If you're a student, you'll get an idea of some of the real-world scenarios. Usually during our time in school, we simplify conditions to learn the basic concepts. For example, neglecting the mass of a pulley or ignoring the effects of this or that. And this benefits our learning in the short term, but it's important to be mindful that things don't work like this beyond the classroom. Furthermore, it might help you guide your academic journeys. You could consider to take classes that you otherwise would have never considered. And ultimately, it'll help you prepare for your future roles in the field. So what is sensor data acquisition? Simply put, it refers to the process of collecting data from sensors. But behind the curtain, they contain specialized mechanisms that react to certain stimuli or a specific physical phenomenon. This reaction is then captured and converted into electrical signals or some other form of data that we can understand. An important tool used in sensor data acquisition are data acquisition or DAC systems. These systems are separate from the sensors themselves, and they just provide an all-in-one system that takes care of most of the complexities of obtaining data from the sensors. Another important aspect is data transmission, and this deals with how the data is getting from the sensors to its destination. You have to think about where the data is going to be stored. How is it going to get there? Will it be wirelessly or through cables, or does it need to go anywhere at all? Lastly, when we talk about the field, we're talking about the real world. These are unpredictable operational working environments, and it's the researcher's goal to accurately reflect those environments in the data that they collect. So some of the external challenges go beyond the specifics of the sensor mechanism. They're related more to the practical application of these devices in the field. And these are challenges that the designers generally don't need to think about. Most times, sensors are designed to operate under a specific set of working conditions, and the designers aren't worried about the challenges of replicating those conditions in more complex environments. That's up to the users of the sensors to ensure that they can operate properly wherever they are. So environmental challenges refer to those difficulties posed by the physical and the atmospheric conditions that the sensors might be subjected to while collecting data. This can disrupt the operation of the sensor, it can cause damage, or just data inaccuracies. Logistical challenges involve the difficulties related to organizing, deploying, and maintaining the sensors over their lifetime. It requires careful thought and planning to ensure that reliable and efficient data is collected from the devices. Data quality challenges, this is related to challenges when the data can be inaccurate, just wrong, or missing. And these are usually a direct result from the other external factors posed by the field, or it could be a result from the limitations of the hardware itself. The human factors relate to the influence of human involvement in the data acquisition process. They can stem from errors in installments or maintenance, lack of proper training, or just poor documentation and protocol. So here's some environmental challenges. The weather is a big factor contributing to data integrity issues. It can cause damage to the sensors or place them in conditions that fall outside of their operating ranges set out by the designers. Extreme temperatures can cause the sensor readings to drift. It can cause the electrical components inside to expand or contract, which also contributes to drift. And it can also make the battery or the power supply become extremely volatile. Electromagnetic interference mainly affects the data transmission. It causes data loss or corruption. And it usually refers to the external electromagnetic fields that the sensors might be exposed to, which are abundant in the field. They can come from other electrical equipment or industrial machinery that has a lot of mechanical movement. The vibration refers to the continuous oscillation or movement, while shock refers to more sudden, forceful impacts. Both of them can cause damage to the electrical components of a sensor, or they can cause the sensors to become misaligned. You can look at either reducing these effects, or if the sensor is built to handle or measure these things, you can come up with a good mounting strategy to prevent misalignment. The biological contamination refers to the living organisms that might be present that would affect the sensor use. Animals and insects can damage or just obstruct sensors, especially in remote locations. And microbial growth or films can grow over the components given the right environmental conditions and a lack of maintenance. So what are some solutions and best practices to help overcome these environmental challenges? This might seem trivial, but selecting the right sensor for the job initially can help avoid these challenges. You have to carefully consider those environmental influences that the sensor might be exposed to, and make sure the sensor can operate under those conditions. You can also take a sensor that might not be suited for these conditions and try to protect it by selecting the proper case or the right mounting mechanism. You can try to mitigate the electromagnetic interference when possible. Some common strategies for this include shielding the wires or the data transmission medium, using twisted wire pairs, selecting sensors that produce low noise initially, or having a well thought out deployment plan. Regular maintenance is essential to pretty much all sensors, and this should include inspections for any physical effects that the environment may have had on the sensor. For example, dust could collect or fractures in the sensor's exterior could go undetected. So there are methods to reduce mechanical shock or vibration. Devices like shock absorbing mounts, vibration isolation pads, or other damping systems. Additionally, placing sensors in areas that are less prone to vibration or using post-filtering techniques of the data can help ensure that you're still collecting meaningful data that can be used. Collection of redundant data is also a strong method for protecting against the data, protecting against inaccuracies of sensor data collection. It involves the collection of extra data from multiple sensors that can be used to verify that the sensors are functioning properly and the data is accurate. So some of the logistical challenges address the question of how. Let's say there's data that you want and you pick the right sensor for the job. You've considered all the environmental factors that would affect the sensor. Now what's the plan? You need to think about things like how are you going to deploy it? Where is it going to be deployed? Should it be accessible? Who should access it? So many sensors are also not plug and play, meaning that they don't come ready to use. Most of them require some initial configuration and sometimes calibration. Some elaborate designs of sensors make this really easy for anyone, and it might even come with an app, but other low-cost sensors usually require some lower level knowledge about the specific protocols that the sensor might be using. Lifetime and maintenance are related to the power supply and the energy management. Sensors need to be powered constantly while sensing, and they need regular maintenance to ensure that they're operating as they should. When thinking about power supply over the sensor's lifetime, there could be inefficiencies related to the powering devices while the data isn't being collected. So you also have to consider where the data is at all times once it's collected. You could be using a DAC system or sending the data to one central storage unit. Without careful planning of where the data is at all times, some data could be lost, and maybe it could be gone, or maybe it could just be somewhere and nobody knows. This is more a problem with larger companies that have more complex organizational structures. The sensors do come with a varying degree of initial and variable costs, which can limit the selection of the sensors or the efficiency of implementing them in the field. Supply chain and inventory management involves managing the availability of these sensors or the resources needed to operate them. Do you have backups? Are backups readily available, or would it take months to come in? The availability of skilled personnel to install and maintain or troubleshoot sensors can also affect the efficiency of deploying them in the field. So some strategies to deal with the logistical challenges is, of course, to plan ahead, figure out all the details of how beforehand. You could conduct multiple field evaluations or consult with everyone that might contact or come near the sensors. Implement remote calibration and configuration techniques. Maybe you want to try a sensor that already has these capabilities, or there could be a DAC system that can allow you to interact with sensors remotely. This will limit the amount of times a sensor needs to be remounted and unmounted, and it also just limits the physical interactions with the sensor. Drawing up good power consumption plans and managing resources efficiently can reduce the cost to operate the sensors and ensure successful long-term implementation. Low power or energy saving modes usually are offered by these devices, and they should be used during idle time when the sensors aren't collecting data that's usable. This could be someone's responsibility, or sensors can be automated according to a schedule. You can conduct a cost-benefit analysis that can help you justify the deployment of these sensors in the field. Furthermore, you could conduct a cost-benefit analysis for multiple sensors to help you decide on which one to use. Edge computing refers to the processing and the storing of the data on board the sensor itself. This is where you can avoid the challenges of data transmission altogether. The data can then be transmitted periodically under more stable conditions, or someone could come and collect the data manually. Using mesh networks are also being used as a common strategy to deal with the issues with data transmission. So before mesh networks were used to connect multiple local area networks that are spread across a wide geographical location. But since the late 2000s, they are now used as local area networks themselves, and you could find them in homes, on campuses, or on work sites. So what it does is provide multiple paths for the data to travel so that should one path get overloaded or damaged or obstructed, the data can still reach its destination. Ensuring that all procedures that involve interacting with these sensors, either physically or remotely, are standardized and documented. This can ensure that nothing is missed in terms of maintenance and can really help trace errors that are made. So challenges in working with these sensors. Worker training dictates the level of knowledge that workers have access to about the operation or the troubleshooting of the sensors, or just working alongside them for whatever purpose, whether that be research interest or just safety protocol. Inadequate training can lead to sensor misuse or efficiencies in using them in the field. There can be human error in sensor deployment and maintenance that doesn't really have anything to do with a lack of knowledge or training, just the fact that humans make mistakes. Communication and coordination is essential to maximize the efficiency of data collection. Right? Everyone working with the sensors has different skills and backgrounds, but everyone should still be on the same page. Other pressures at work or cognitive overloading deals with the mental fatigue that you can begin to feel when given too many tasks or just too much to think about, sometimes in already stressful environments. This can affect your performance at work, or it could also follow you into your personal lives. Sometimes workers can lack drive or incentive to work with these technologies, and this is amplified by not understanding the purpose for having them in the first place, especially when they're new or actively being integrated into company protocols. Technological dependence is when workers can begin to rely too much on sensors and begin to overlook certain things at work. Conversely, sensors that act as indicators may constantly produce false detections, and then the workers begin to ignore them completely. Sometimes the workplace culture or the safety culture can really affect the attitudes towards the technologies, which have a huge impact on the effectiveness of using them in the field or incorporating them into your health and safety strategic plans. So some solutions and best practices is having comprehensive training programs for anyone exposed to or working around these sensors. This can really improve the process of acquiring data and really help make sure that the sensors are being used as efficiently as possible. This training should be personalized and include the motivation behind using them. Again, clear documentation that uses checklists for routine procedures can limit the possibility for human error and make working with these devices easier for anyone. Having someone oversee the integration of sensors in the field can help manage these human-related challenges as they arise, maybe until proper procedures are in place and it eventually just becomes part of the day-to-day operations. Supporting and communicating with anyone that will be working with or around the sensors facilitates quick responses to any environmental or technical issues that might arise in the field. This approach not only improves the efficiency of data collection, but it strengthens the workplace safety culture by promoting collaboration. It also fosters a safety-conscious environment where workers feel comfortable raising concerns, sharing insights, and learning together to address these challenges. This ultimately leads to a more proactive and safety-oriented culture where everyone feels like they're contributing to the safety plan. So regularly collect feedback from workers exposed to sensors. They should not be invisible. So mounting sensors in discrete locations might keep them out of sight, but ensuring that workers know they're there and that they're actively monitoring conditions can enhance the safety awareness. Similarly, by regularly collecting feedback from those exposed to these sensors, you ensure that workers are seen and heard, which creates a culture where both technology and the people using it are integral to the safety process. This visibility strengthens the overall culture, encouraging a sense of shared responsibility in the field. So as we've seen today, working with sensors in the field is much more than just collecting data. It's about understanding the environment and the challenges that arise and how we can overcome them. The more we recognize the limitations of these tools, we can better manage them and use them to improve our workplace safety and health. Whether you're in research, safety management, or on the front lines, the key takeaway is that thoughtful planning and awareness can help turn sensor data into powerful insights that drive change and improve the work conditions for all. So thanks everyone for listening, and now I'll open the floor to any questions you might have.
Well done, Camden. There's a couple of questions in the Q&A. The first one is from Dushyant Singh. Is there any way to identify if a sensor used at a workplace or on a workplace equipment is low cost, or why it keeps shutting the equipment for the reason it's supposed to? I'm not sure if I've got that right. When that's not the case.
I'm not sure if I understand that too.
Yeah, like maybe do you want to clarify, Dushyant, in the Q&A? I don't think I'm asking that properly. Marcia has I think made a comment just saying excellent research, and consider regarding environmental challenges in depth underground. Some direct reading instrument sensors do not enjoy functioning underground or rapid changes in their depth underground while traveling vertically. I don't know if you have any comments about that.
Yeah, that's probably some just more sensor specific challenges. I should have definitely went into maybe applications to mining. That would have been really good. I also had like a slide on specific challenges that the certain mechanisms used by various sensors could pose. And yeah, sensors, depending on the mechanism that they employ, will have different challenges that they experience. Like accelerometers, they can be MEMS or piezoelectric, and they have different capabilities just in the hardware themselves.
Okay. Bernard is asking, can you elaborate on using sensors and digital twins to protect worker health and safety?
Yeah, so that's probably talking about data redundancy. You can use multiple sensors, and if you employ multiple sensors in the field, you can use them to verify each other, or you can employ multiple lower cost sensors, and then you could have one gold standard, and that way you can compare the lower cost sensors to the gold standard to ensure that they're functioning properly. There's also another form of data redundancy where you can copy data and just store it in multiple locations. This improves the data integrity and just the security of storing it.
Okay. And we've got a comment from Lise. She says, so many occupational health sensors have significant interference. It's important to understand all other agents possible. And then Dushyant, I think, has clarified. He says, we have sensors on our forklifts, and they are called impact sensors, and our trucks keep locking when there's no impact, and then the truck shuts down while they're driving on a plane surface. So I guess it's a comment of any idea why the equipment is failing. And I think going back to his opening question, is that a function of the cost of the equipment? Like maybe it's too cheap.
It might not be related to the cost, because even the most robust sensors can have those false detections, and that's usually a problem with fault detection sensors. It's a decision to have the sensors take control away from the operators, but you can employ different strategies to overcome that. You could just maybe have an indicator instead of where it takes over control, And then the operator of the forklift would have to look at the indicator instead. But that just goes back to the safety strategy of the company and what they want to do with it.
Right.
But again, they should, as part of their safety strategy, they should hear your complaints and you should make that heard if you've never voiced that
Yeah,
to them before. So maybe they could implement
fair.
something better.
All right, we're a little bit out of time, but I'm still going to ask you, what was your favorite sensor that you used and why?
I think it was the most fun to work with the accelerometers just because it was fun learning about the challenges. And the biggest challenge with that was I don't think we've ever actually overcome it, but it's synchronization of different signals and simultaneous data acquisition. That poses to be a very complex challenge. And I think it came more down to the hardware that was available to us. So we were trying to make things work with lower cost sensors. Yeah, so that's the most challenging thing is working with the hardware that you have